Okay, so let's suppose I have f of x. I'm going to choose a function from your book. Oh, sorry. Okay, I'm looking on page 230. And I want to choose a function like 38. And that is the absolute value of x plus 3 divided by x plus 3. And we're asked a lot of things. To find f of 5, to find f of negative 5, to find f of negative 9 minus x. And I'm going to add a few, like f of negative 3. I also want f of 0. Nothing matters here. Nothing. Before I identify or I understand what the function is telling me. They can ask anything, and I will be able to answer to any question as long as I understand what the function is telling me. This is what the function is telling me. This is what the function tells me. The function says that when I apply it to whatever I want, I get a fraction with the absolute value at the top, whatever I want again, plus 3, and in the denominator, whatever, that thing, the same thing, plus 3. This is what the function is telling me. Now this is basically a piece of cake. Once I understand that pattern, the rest is just nothing, really. Just waste of time, in a way. So when I put 5 here and 5 here, then I put in negative 5 and negative 5, and then I put negative 9 minus x, negative 9 minus x, negative 9 minus x, then negative 3, negative 3, negative 3, and then 0, 0, 0, and I'm done. So for the first one, f of 5, I will have 5 plus 3 in absolute value, which is 8. So the numerator is 8, the denominator is 8, so the answer is 1. Now careful. When I plug in negative 5, I have negative 5 plus 3, which is in absolute value 2. But now negative 5 plus 3 is, so the answer in this case is negative 1. So now the ordered pair that I just determined for these two functions, or the ordered pairs, what are those? Perfect. 5 and 1, negative 5, negative 1. I know we're not finished, but I wanted to emphasize that. Any questions, please? Is this okay, everyone? Okay, now I reached this. The same thing. F of negative 9 minus x is, now I have to write it, negative 9 minus x plus 3 over negative 9 minus x plus 3. Let's see what we can do here, if we can do anything. And yes, we can. What is negative x? I have to copy it in descending order. But now I know that negative 9 plus 3 is negative 6. The denominator, I copy negative x, and negative 9 plus 3 is negative 6. Okay, and leave it alone. Now when we plug in negative 3, f of negative 3 is negative 3 plus 3 at the top and negative 3 plus 3 in the denominator. What does this mean? The numerator is 0, the denominator is 0. We don't know this. You could say it's undefined, but it's not. It's called an indeterminate case. You do not need to know that. Okay? So you know that you cannot calculate this. Indeterminate cases are dealt with in calculus. But you know that something is wrong. Nothing works here. 0 over 0 is not a number. That's all I was pointing out. Finally, f of 0, it's 0 plus 3 over 0 plus 3. So f of 0, yes. So 0 plus 3 in absolute value, 0 plus 3, the top is 3, the bottom is 3, and now I know that is 1. I can write the ordered pair as 0, comma 1. Any questions? Any questions?
Can you go back?
Yes, yes.
Listen, and I don't mean to sound any type of way. I'm just, why are both of the, never mind. Don't worry about it. I got it.
You answered your own question?
Yeah.
I love it. Questions? Questions?
The absolute value is negative x, so if it comes to a problem like that.
That is,
stop it.
you're not going to.
Okay.
You're not going to take it any further. But what happens to that is, as we know, there are two different options. And yes, we can simplify that. We can. So one expression will be positive 1, the other one will be negative 1. We can. But in this class, there is no need to do that. Yes, we do that in calculus and pre-calculus, of course. We have to simplify it because something else follows. But in this class, it was just evaluating. Yeah. Good. So let's take a look. We're not done with 2.1, but I just want to talk. I still have about 10 minutes roughly. I want to talk about something very important. It's called the difference quotient. The difference quotient. And you can say, what is it? And I'll explain. I want to explain from details. Okay. I have this graph. Is this a function? By the vertical line test is a function. On this function, I'm going to pick 2 points. I'm going to call point 1 P and the other one Q. Like any point on the coordinate system has to have an x and a y, x and y, correct? I'm going to tell you the x for P. I'm going to tell you the x for Q. Let me explain what this means. Are P and Q close to each other? Of course not. But I have to zoom in. They are actually extremely close. The x-coordinate of P is x, and the x-coordinate of Q is x plus a little bit, tiny bit, less than 1, tiny. But if I plot or I present Q right here, I'm not going to be able to show you anything. So just keep in mind, I'm zooming in, so P and Q are very close to each other. The x-coordinate of P is x, and the x-coordinate of Q is x plus a little bit. That little bit is denoted by lowercase h. Okay. So this is a tiny bit. Small, very small number. Okay. So then P and Q are something like this, very, very close to each other. Okay. Now I would like you to give me the y-coordinate of P, and I would like you to give me the y-coordinate of Q. If the point is on the function and its x value is x, what is its y value? Correct. In another way, how do we write the y? Exactly. There is one other way of writing y. It's right there. It's already written. Point it out. Point it out. It's right here. Thank you very much. If the x-coordinate of Q is x plus h, what will be the y-coordinate of Q? Of course. Exactly. Exactly it. F of that x value, of course. Great job. Thank you. Now I'm going to draw a line that goes through PQ. And I would like you to give me the slope of this line. How do I write the slope of this line? Yes, please, Steve.
If I recall correctly, the slope formula is y2 minus y1 divided by x2 minus x1.
Good. And in terms of what we have here in the graph?
With x2, we're going to have it as the cube set. So it's going to be x plus h, or parentheses x plus h.
It has to be a y value. X plus h is not a y value.
So,
Well, right,
That's
it's gonna
what-
be f of x plus h
Very good.
minus f of x.
Wonderful. Over.
x plus x plus h.
Good. We cannot have f of x in the denominator, right? The denominator has to have only x, only the numerator has the y, the rise. These two go away. So then I have f of x plus h minus f of x divided by h. This is the difference quotient. But what is it, really? Okay, now I threw a formula at you because actually you came up with the formula. I didn't do anything. I just pointed out in the right direction, pointed you in the right direction. But you came up with the formula because it's the slope of PQ. But my question is now, what does this difference quotient represent? Keep in mind that this is the rate of change of a function between 2 points. So I get in my car right now and I go to New York and I drive 200 miles and you will ask me, okay, give me your rate of change, the average rate of change. So I will determine the speed at the end minus the distance at the end minus the distance that I started with divided by the time, and then I'll tell you what my average rate of change was. But in this case, when these 2 points are so close, Q is right here, this will give the rate of change pretty much at a point, which means you call me an hour and a half from now and you say to me, what is your speed? I look at the odometer and I'll say 65. That's the instantaneous velocity. But if you ask me, tell me what was your average rate of your speed between Wilmington and Delaware and Philadelphia, then I have to calculate this ratio. Distance minus distance over time minus time, and I'll give you the average rate on that portion of the road. But if you ask me, you call me and say, look at your odometer, what is your speed? I'll say whatever it is, and that's the instantaneous velocity, and this is pretty much what this gives. The instantaneous rate of change of the function. Okay? Why is this so important? Because we need to learn in this class how to evaluate the difference quotient for different functions. And I have 5 minutes. Let's choose a quadratic function. And then we'll stop. Last problem. So please give me a quadratic function for which we want to calculate the difference quotient, which is almost the instantaneous rate of change at any point on the graph of the function. So dictate a quadratic function, please.
Well, it's 4 squared
Excellent.
plus 5x plus 2.
Okay, minus 2. So we have a minus in there somewhere. Very good. The difference quotient in this class will be given to you. You do not have to memorize it. So you already told me what it is. I'm just going to copy it, right? We know that. In pre-calculus and calculus, my students have to remember this. But here we will be given to you. Okay. So I see here 3 pieces. I see one piece, I see another piece, and I see another piece. Which of these 3 pieces I can't do anything to? Or which pieces from these 3 I can do anything to? There is nothing I can do, or I cannot simplify, or there is nothing I can do to simplify. No one can do anything to h. No one. No one can do anything to the f of x. It's right there. We chose it. That's it. No one can simplify that. So I do have only one piece that I need to work on. That's why we did what we did before the difference quotient 5 minutes ago. So I need you to identify this for me. Please tell me what to do. Remember how to read a function, and you will tell me the correct steps that I need to write. And I'm ready when you are. Last night I told one of my students, my calculus students in Arnold, they were waiting, and I was waiting and waiting for them to say something. I said, my markers are drying out. And they said, yeah, because they're cheap. I said, okay, I'll show you cheap. So, yes, they're very funny. Okay, my markers are drying out. Don't say they're cheap. They're not cheap. So, please. I have to copy 4, then. We just did this 5 minutes ago. Thank you. Very good. X plus h squared plus. And? Very good. And minus 2. Awesome. I don't want to talk about this. This was our first class. Please make me proud. 4. My cheap markers are drying out. Yes, x squared. 2xh. Very good. Plus h squared. Our first class tells us that when we square binomial, how many terms do we get? 3. Thank you. Indeed, 3. Plus 5x. Plus 5h minus 2. I distribute. 4x squared minus 8. I'm sorry, plus xh and plus 4. Plus 5x plus 5h minus 2. All this will replace this. 2 things have to happen here. But I'm running out of time. It's just one minute left. So I'm going to finish it up on Monday. So 2 things have to happen, but I don't want to move forward beyond that. I have to explain what things have to happen here. So do not continue with it. I need time to finish it up.